Hello, I'm Bobsy, and I'm gonna try and make a new series. This is my first video called Unity Basics, and I want to introduce you guys to the absolute basics of Unity. Now, to begin with, I want you guys to know that these videos are not gonna necessarily have a particular goal unless I'm requested to do so. We're mainly aiming to try and help you get a better general understanding of the programming language and working with Unity. So whatever that we're doing and programming are not necessarily going to be directly useful, but it's definitely going to help you improve learning and improving your understanding of Unity as a general. So first of all, you're going to be able to see timestamps at the bottom of the video, and if any of these things you're already done with or have done or know of, feel free to skip to the next part. So to begin with, we're going to look at installing Unity, which in Unity Hub, you go to installs, you click add, you typically just want to select the recommended release, click next, and it's important that you keep Microsoft Visual Studio Community ticked and that you keep the documentation ticked, and you simply hit next and start installing Unity and Visual Studio. This will require you to restart your PC. Yeah, that's about it. Then you hit the projects and you click on new. I am going to select the newest version of Unity here on my list because I have a lot of versions of Unity. And I'm going to make a new project. I'm just going to call this one tutorial project. And it's going to be in 3D space. These are pretty much prefabs. You can change between 2D and 3D further on, but I'm going to stay in 3D for now. And hit create. This process will typically take about 30 seconds to 1.5 minutes to set up, you see. So here we see Unity set up. As you can see, mine will probably look a bit different than yours. This is because this is the setup that I prefer. I have the scene view and the console on the left, and then I have the hierarchy, the projects, and the inspector window on the right side. It's really important that at all times you can see your scene view, your hierarchy, your projects folder, and the inspector view, and that's really about it. Getting familiar with this and setting it up a way that feels good to you is very important because you're going to be looking at this a lot. If you want it the easiest to follow this tutorial, feel free to pause it and set up your Unity as mine is. First of all, I want to advise you to go to Edit, go to Preferences, and go to External Tools and make sure that your external script editor is set up as Microsoft Visual Studio 2019. If you have any problems with this, leave a comment and I'll guide you through the process. Now, in Unity, it's important to get familiar with the controls. This is the scene view to our left, and if you hold right click, you can look around as if this was a first person game. Using WASD, you can fly around the scene view in 3D space to be able to set up your scene. So let's start by setting up a simple ground, which we're going to right click in the hierarchy, or we can press the little plus up here. We can go to 3D objects and you can select plane. A plane is just a flat one-sided object. It could also be a cube that's our ground, but for this sake I'm going to select the plane and I'm going to call it ground. I'm going to scale it up on the x-axis to 3 and the z-axis to 3. Because these are on the flat axis. I don't want it to be taller because it actually doesn't work like that. Since it's a plane, as you can see here, it is one-sided. So if I go under it, it's invisible. And that's good for optimization and stuff, but it's not like our game is going to be particularly heavy at this point. You also always want to make sure when you create a new game object, it's just really nice to make sure you set the position to 0, 0, and 0 in the X, Y, and Z axes. You can also, when you create the object, right click the transform and click reset. That will reset everything back to 0, 0, 0 and 1, 1, 1 for the scale. Now, right now it's a bit hard to see any sort of depth in this just plain white plane. So if we go to the assets folder and we right click and we create a new folder and we call that materials. Generally, you want to have a good folder set up to make it easier to navigate, because as soon as you start making larger scale games, start understanding Unity more, you will also start realizing that it will become very messy if you don't organize your things correctly. So if we enter the materials folder, we can right click and go to create again. And then around the center of the create bar, you have material. And here we want to make a new material and name it ground. I'm going to give ground the color of, let's say, a nice shade of green. And then you can actually just drag and drop the ground material onto your plane. You can see it immediately turns green to the color that I chose, but it's still quite difficult to see depth. So I can go next to where it says albedo on the little circle, and you'll be able to click that little circle. It will open up the texture window, and Unity has some default textures for you to use. For materials such as this, where you want to be able to see depth and size to them, I would advise you to take the default checker gray. Simply double click that. If we go down to tiling now, as you can see, the tiling right now is just 1:1, which makes this still very big and very hard to see size scale. But since we made our ground object 3x3, you can make the tiling 3x3, but I actually prefer making it twice the size, so making it 6x6. I feel like this is much better to be able to see depth and movement of stuff, so you can actually see a bit of distance and size perspective. Now we want to go and right click and create a new, and that can be a cube, a sphere, whatever you want it to be. Play around with it. It doesn't matter the object for my sake. I'm going to make a cube, and I'm just going to keep it named cube. You can name it whatever you want. It doesn't matter, but I'm going to stick to cube. We're going to reset the position to 0, 0, 0, and I'm actually going to drag it just a little bit above the ground. And if you want to, you can also briefly make a new material for it. You can call it cube, and this cube material we can make a reddish color and apply that to our cube. So there we go. Now it stands out a bit more. Now we also have the camera here. If you go to the game view, or for that sake press play, you'll just be seeing this. And this isn't a very nice angle. It's difficult to see 3D space. You know how far away or close the cube is to the camera. It's not very easy to see. So I personally would prefer to move the camera a bit to the side, a little bit up, maybe rotate it a bit down, and a bit to the side. And there we go. Now we're looking down on the cube instead. Now the controls that I just switched between, you'll find in your top left. You'll find your moving tool, your rotation tool, and your scaling tool. These are on these are on W, E, and R, which was what I did to make it quicker. It's good to get used to these. Another thing that's good to note, if we just go to the rotation especially, up here it says global, which means that the rotation axes that you see here will be on the global scale, which means they won't rotate with the object. But if we click the global up here and set it to local, you can now see that this rotation will now be dependent on the rotation of the current object. So that means if we rotate it sideways now, it's going to get a little bit wonky, which is why when you rotate stuff, generally it's much easier to be in the global state, but it's good for other things. So now it's nice, we're looking down sideways on the cube. I like that. Now let's talk about what our cube is going to do. I want to introduce you to some simple concepts. I want to teach you how to reference your own game object. I want to teach you how to reference another game object. And I want to teach you how to use if statements and how to transform the position of objects and do that over time as well. Now, the reason why I'm keeping it so simple is what we're basically doing here is we're going to try and make our cube move over time when we press a button towards a target position that we can set ourselves. So with that in mind, we want to right click on the hierarchy and we want to say create empty. This is because we don't want to be able to see this object. I'm just going to call it target because this is what our cube is going to move towards. Now I'm going to make it 0, 0, 0 again. And then you can just place it wherever you want, a little bit to the side, a little bit up. It doesn't really matter because we're going to be able to see the difference later on when we edit it. So if we go back to our assets folder down here in our project folder, and we right click and create a new folder and we call that scripts. This is again a good way to organize where we keep all our scripts. And in here we can create a new C# script, which I am going to call cube control. You can call the script whatever you want. Remember, don't make spaces. And every time that you capitalize a letter, Unity will automatically make a space for you. So you can see down here, I haven't made any actual spaces in the name. But up here, when you see in the inspector window, you'll see it says cube space controller. So now if we go to our cube object, we can drag and drop the script onto that. And now everything that we code in there will be activated from our cube script. This also means that we can reference the cube object via the script very easily because the script is attached to the object. But we will also want a way to be able to target or to use our target object or to reference that. So we can double click the controller script out here. We can click it in here on our object. So I'm just going to double click it in here and we're going to open up Visual Studio Code or Visual Studio, my bad. We just need to start by deleting all of this and I'll explain to you what they do later. So we just delete everything that's inside of these brackets. You want to keep these brackets because they're pretty much the whole class of your script. So you want to type everything that you type inside of these lower level brackets, or lowest level brackets I should say. So first we wanted a way to reference our target object. The way that we target our object, or we reference our target object, is by calling a public variable, which is going to be a game object, and we're going to call that target. Don't worry, I'm going to go this through with you. Now when you make variables, make sure that they start with a non-capitalized letter, but if you want to make it longer, like target object, you can write it with a capitalized letter here. And it will, again, in the Unity window, automatically capitalize the first one, and it will automatically create a space here. But you don't want to make spaces in code. It doesn't work like that. I'm just going to keep it as target. Now let's go a bit back. I wrote public here. Public means that other scripts, or the Unity inspector for that sake, can actually reference this object, can see this variable that we're making. And where we write game object, we're defining what is it that we want to reference. In this case, we want to reference a game object. So if we go back to the Unity, and we take a look in the inspector, you'll now see a new line will appear at the cube controller script saying target. And keep in mind that this is capitalized even though we didn't capitalize it in here. And that's again just how Unity understands variables. Now you can see it's looking for a game object, but currently it has none. But we can actually grab our target game object from out here and drag and drop it into this view where it says none currently. And you can see now it's referencing target. So that means right now, every time in our code that we write target, it will know that we're trying to reference this target object. Now, even though I keep referencing to it as an object, even though it actually you can't see it and no one can touch it, it's still there. It's pretty much right now everything it has is this transform module on it, which holds a position, it holds a rotation, and it holds a scale. Now what we want to use is solely the position. So keep in mind that our cube also has one. Every object in Unity has one, even the directional light, even the camera, everything has a transform. So what we pretty much want to do to begin with is that we want the cube's transform position to be equals to the one of target transform position. And so if we go back to our code, we want this, so whenever you modify something on the go, you want to use what's called a void update. The reason why we use a void update is because what a update function does is that it's something that Unity already knows, and every single line of code that we write in here will be updated every single frame of the game. Whereas if we used a start function, now you don't have to write this, I'm just explaining. If we use the start function, this is something that's only being called on the very first frame of the game. So, or at least that the game object is active. So that means that we can use this to actually set variables with. So for example, if we had a variable that was called speed, we can down here set it to 2, for example, and it will set the speed at the very beginning of the script to 2. But we're not going to use this because we want to update on the go. We want to keep updating the position of our cube. So right now, to reference our cube, since the script is currently attached to the cube, the way that we reference the cube is just by writing gameobject with a non-capitalized g at the front, or a lowercase g. Now when writing this, we automatically reference the gameobject that the cube controller is attached to. And then what we want is we want to grab the transform, and we want to grab the position under the transform. So we're going to write .transform.position. And now we're editing this. Right now we're saying to Unity, hey, get this. And now we're going to tell it what to do with it. So by writing equals, we're pretty much saying we're going to define what the game object's transform.position is going to be. In this case, we're already referencing target, and we want to, on the target, we want to grab the target's transform position. So what we can write here, instead of game object to reference, because that would reference our own game object, we can write target, because that's right now referencing an external game object. We're going to write target.transform.position. And you'll always end every functional code or line of code with a semicolon. So if we go back out to Unity right now, and we start the game, you can actually see with just these two lines of code, one variable and one functional line of code, you can see that the cube, if we go back to the scene view here, and we grab the target, not the cube, but the target, when we move the target around, you can see that the cube is now stuck to the target. And that's because we are constantly telling the game to set the cube's position to be equals to the target's position. So when we move the target, we also move the cube. Now, we want this to happen over time, of course. So if we go back a bit, we're going to need something else here, because this is technically a math-based problem. We want the 3 individual numbers on the cube's position to, over time instead, start moving towards the position of the target. So we want, for example, this 0 should start over time to move towards 3.49 and so on with the y and the z axis. But the way that we do that is that Unity's, the most 3D software really, they handle in what's called vectors. If you're not familiar with vectors, it can be a bit tricky to understand, but basically a vector is a position in space. So right now we have space, and right now Unity has just defined that right here, if you look at the ground object, right in here where this is 0, 0, 0 in world space. So that means in all the space of this unlimited universe that Unity provides, this is the center of the universe. So that means that right now what this practically says is, where is the cube relative to the center of the universe? And it's the same for the target. But we want to move this over time. And since we're dealing in vectors, Unity actually has a lot of functionality that can help us. There's a lot of ways to do this. One of the ways that I like doing it is writing vector3 dot and then move towards. And you might say, hey, how would I know this? How in the hell would I know to do this? Google is your absolute best friend. Unity has a great community, it has great documentation. And you can actually see, I have Googled it here as an example before. Unity move object to position over time. That's a very simple line that you could also Google. So if you search for this, and we just scroll down a bit, you can see this is from answers.unity.com, answers.unity.com, but you can see this is from documentation or docs.unity3d.com. So this is the official documentation of Unity, which if you're looking up stuff, try and see if you can find something from the Unity documentation, because the Unity documentation is really good. You can see what this does is pretty much it calculates a position between the points specified by current and target, and moving no farther than the distance specified by the max distance delta. Now this might sound confusing, but what you practically do is that you're taking your current position, you're taking your target's position, and you're saying, hey, move this much closer to it every frame. And the way that we can control this is that Unity actually has perception of time through something called time.delta time. So by using move towards and using what we know here, you can see it's set up. Because it's a function, you can see it starts with a capital M. And a function always has something functional or function-wise inside of the brackets. So in here you can see we wanted, first of all, we want the current position. So we actually want our own gameobject position, which means we can just take this and copy paste it in here. And then you always split things up with a little comma. So we're gonna write comma, and now we need the target.transform.position. Now we have the 2 positions identified. Now we just need to tell it how much to move every frame. And the way that we do this is pretty much through time.delta time. And time.delta time is pretty much a variable for a second. One time.delta time is 1 second. So right now we're technically telling it, if I go back to Unity, and it's just gonna load, we're technically telling it that it can move 1 position per second. So it will move, so if we go from 0, look at the cube here, we can just go a little closer. And if we move 1, this is how far it will move over 1 second. But we want to be able to change this and modify this. So we're going to set another variable. And I'm going to tell you all about these variables sooner than later. So if we write public again, because we want to be able to edit it again from the inspector. And then we can write int or we can write float. Both of these are good. Ints and floats are both numbers. The thing is, integers or int, they deal in whole numbers, and floats, they deal in decimals as well as whole numbers. And you might ask, why wouldn't I just use floats all the time then? And you could absolutely use floats all the time. The thing is, there might be certain situations where you don't want to use a float all the time. For example, if you take something like, think of one of your favorite games that displays how much health you have. How many games tells you that you have, 10.3 health? No, they're gonna tell you that you have 10 or 11 health. And that's one of the reasons why you would want to deal with integers instead. So places where you don't require to have decimals, you would use an integer. And in our case, I don't feel like we need decimals. So I'm just gonna use an integer, say equals, and then you can actually set it, I'm gonna give it a name, call it speed. And you could just stop it here and then just change it from the inspector. But you could also give it a default value, which means if we gave it nothing in the inspector, it will refer to this value. So I'm just going to hit 2. And the way that we now apply this in this piece of code, because right now we just have the variable. It's not being used in the code anywhere. And we actually just times this by delta time. So we're going to take times the delta time, and we're going to say multiplied by speed. And it's just that easy. Now we've just added our own speed as well to it. So if we go back, you'll now see that speed will turn up as a variable on the script, and you can edit this. So if we just start the game, you can now see that it will start moving over time instead. If you go to the scene view, select the target, and move the target around, you can now see the cube will start moving towards our target over time instead. This is nice, and you can go to the cube and you can modify the speed, so we can put it to like 15, for example, to make it really fast. And we can move this around. Now you can see the cube will follow our target much faster, because we're technically modifying the time it takes to move one extra on the position X, Y, or Z value. And this works for all different ways, by the way, just so you know. So this is nice. This is fun to play around with. You can definitely play around with this. I'll introduce you to physics in the future if that's something you're interested in as well. But let's move on. Now, as I mentioned, we want this to happen by the click of a button. I want to introduce you guys to if statements, and I want to introduce you guys to the input system. So if we just add a line in front of, or it could be after, it doesn't matter in this scenario. We're going to write if, and an if statement is always set up the same way. You open and close your normal brackets, and then you actually open curly brackets, as you do with these functions as well. And whatever we put into this if statement, just going to make it a bit larger. Whatever we put into this if statement will actually determine whether this code runs or not. So if, for example, you put in something in here, so you pretty much have to give it something that's either true or false. That could, for example, be, hey, you know, is 2 larger than 1? And if 2 is larger than 1, well, then it will run the code. Well, right now, obviously, we know that 2 is larger than 1, and it's always going to be larger than 1. So right now, this code will run always. And this could be some other cases, you know. You can give it mathematical equations if you want to. You can input, you know, hey, if the speed is larger than 1, for example, well then, which it is right now, the code will run. But if we set the speed to under 1, it won't run. But what we want to do in here is actually we want to check if the user is pressing a key, because when a user is pressing a key, it actually returns true or false. So if you're pressing the key, it's true. If you're not pressing the key, it's false. So what we want to do is we want to write input.getKey, and this is of course something you can Google as well. You might say, well, how the hell should I know that? And again, Google's your best friend. It's very easy to Google how the Unity input system works. There's a lot of documentation on that. But you will see that we get the options for get key down, get key, or get key up. These are practically the 3 options we have. Now, get key down activates the second and the first frame that you press the key. So that means that once I press the key, it will activate once. And do you remember what we said about that? That was not what we wanted. We wanted it to constantly update. Get key up, on the other hand, updates the second that you let go of your key. And the last one, get key, well, it updates as long as you are holding the key. Constantly, when you're holding the key, it will constantly send the signal if it's true or false. So we want to use get key. And then again, you can see this starts with a capital G. So therefore it's a function and it needs the brackets. And in the brackets, we want to define what key is this that we're using. You can also see it if we hold over get key, you can see it says key code and then key. So we want to write key code dot, and then we want to give it whatever key. In our case, we can do space, but you can do W, you can do one of the arrows, you can do whatever you want, but I'm going to do space. Now we want to take this piece of code that we have, and we want to put it inside of the brackets for the if command. So you can see the if statement has these brackets, the update has these brackets, and so on. It's these lines typically will make it easy to follow. If you don't have these lines, you can just click right in the beginning of the brackets, and it will actually highlight which bracket it's connected to. So now what the code says is if it gets the key down space, it will run this code in here. And if it doesn't, well, nothing will happen because we haven't told it what will happen if it doesn't. So let's go in and test this out. And we start the game and you should see nothing should move. But as soon as you press space or whatever button you selected, it's going to start moving. And as I let go, it will stop and it will start again. And you'll notice that if you're in the scene view, it doesn't work to press space. You do need to be in the game view up here. So if I move the target, for example, to, I don't know, up here and go to the game view, well, I'll need to be in the game view. If I press space in here, nothing will happen. And we're going to have to stop runtime again. So that's about how that works. If we go to, if we go back to the code, let's try and say that something else should happen. So let's say that we want to be able to move it back to its starting position. So whenever that we let go of the button, it will start moving backwards to where it came from. Well, going through the thought process of how this would work, we would need to, in the beginning of the game, store the position of where the cube is. So at the very first frame, we want to know, hey, where are you located? And the way that we do that is here we can actually use a private variable, because we don't need to edit this anywhere. The code will edit this for us. So we want to choose a private vector 3, and we can call it start position, like so. And now, since it's private, you won't be able to see it in the editor. No other scripts will be able to reach it. Only this script will be able to use the start position. So now we can use the start function. If we go in here, we obviously want to define start position. So we say start position equals, and this is how you always define something. And we want to think, what is the start position equals? And remember, the start function here is on the very first frame. So that means that we can here get the game object with a non-capital G dot transform, transform dot position and semicolon. And now we have the start position here. So this technically means that in this if statement now, we can actually make it, instead of moving towards the target, we can make it move towards this new vector that we just gave it up here, this new position. So the way that an if statement works is you can, by the end of it, also write else and then open new curly bracket, press enter. And in here, this is what happens if this in here is not true. So that means that if this in here is true, it will run this code. If this in here is false, it will run the code in else. So we can actually completely copy this code, yeah, and put it in here. And now, instead of moving towards the target's position, we want it to move towards this start position, sorry, call this start position. And there you go. It should be as simple as that. Now, as soon as we let go of the button, it will start moving back towards its original position, which it has stored. So that means that we can move the cube to any start position that we want. We can move the cube over here, for example. It will remember the start position now because we set it in the code. So by doing this, you can see when I press enter, it will move towards the target that we placed somewhere down here. And then we let go, it will move back towards the original start position because we defined it in the code, because we didn't hard define it. We could also define this position ourselves if we wanted to do that. But it's much better dynamically getting the position in this case. Now, this is pretty much all I have for you. What I want you to go and do now to really get comfortable with this is try and play around with some of the things that you have here. Really, it might seem intimidating to begin with, but we have 3 variables that we've defined, and we have 1, 2, 3, 4 actual functional lines of code. You know, obviously we have the void start and the void update, but codes that we've actually written ourselves, we only really have the if statement, we have the and we have the 2 transform positions, and we have the start position. So we only really have 4 lines of code that we actually wrote ourselves to be able to do this with the game. Now, what I want you to do is go and play around with this stuff. Try and make more stuff happen when you press other keys, you know. Try and make a new if statement that if you press whatever, the arrow up, it will move towards some target position. Or you could play around with placing 4 targets, you know, a target to the right, a target to the top, and left and down, and, you know, defining each of those. And then when you press arrow up and arrow right and arrow down, you will start moving towards the individual targets that you want. You know, and it might seem repetitive, it might seem like a really simple task, but repetition is really key here. You need to get used to and comfortable working with these things. Definitely working with the transform of components and working with if statements and working with understanding how you set up variables. They're definitely key factors to starting to understand Unity. Once you have that unlocked, you can start really working towards bigger things, and I'll gladly teach you how to, you know, make a bouncy ball where you can decide what direction it goes in or something like that. I'll gladly teach you all these things. Please, this is my absolute first video ever. I only recently found out that I really enjoy trying to help other people learn and go through some of these processes that I myself have been through before. I really enjoy it, so if this has helped you in any way, it would mean the absolute world to me if you leave a like, leave a comment, or for that sake even a suggestion on something that you might want to learn, and I can try and make a video going through this scenario. Thank you very much for watching. I hope this was an alright format as well, even though it might have been a bit long. I really hope you had something to learn here, and have a wonderful day.